Have you ever watched a plane soar through the air and wondered, how does it stay up there? It's like magic, right? Well, not quite. It's all thanks to some cool science, including something called the Helmholtz Theorem. This theorem helps us understand the invisible forces that make flight possible. It's all about air, motion, and how they work together to lift those giant metal birds into the sky. So buckle up, because we're about to take a wild ride through the fascinating world of aerodynamics. Think of air not as empty space, but as a fluid, just like water. When this fluid flows smoothly over a curved surface, like an airplane wing, something amazing happens. The air on top of the wing has to travel faster than the air below it. This difference in speed creates a difference in pressure, with lower pressure on top and higher pressure below. This pressure difference generates an upward force, and guess what? That's lift. It's the force that counteracts gravity and keeps the plane aloft. But there's more to the story than just pressure differences. Enter the fascinating world of vortex lines. These invisible lines help us visualize how air swirls and rotates as it flows over the wing. They're like tiny tornadoes that form along the edges of the wing and trail behind it. These swirling vortices play a crucial role in generating lift, and understanding their behavior is key to designing more efficient airplanes. So, the next time you see a plane take off, remember that it's not magic, it's science. And a big part of that science is the Helmholtz Theorem, which helps us unravel the mysteries of flight and design even more amazing flying machines in the future. Keep those curiosity wings flapping. Let's dive a bit deeper into this Helmholtz theorem, named after the brilliant physicist Hermann von Helmholtz. This theorem is like a secret decoder ring for understanding fluid dynamics, the science of how fluids move. It tells us that any fluid flow can be broken down into simpler parts: translation, rotation, and deformation. Translation is like sliding a book across a table. It's all about straight line movement. Rotation is like spinning a basketball on your finger. It's all about things going round and round. Deformation is like stretching a rubber band. It's about how the shape of something changes. Now here's where it gets really cool. The Helmholtz theorem says that we can understand complex fluid flows by looking at these three basic components. In the case of our airplane wing, the theorem helps us see how the air is not just flowing smoothly over the surface, but also swirling and rotating in specific patterns. These swirling patterns are the famous vortex lines, and they are crucial for generating that all-important lift. So the Helmholtz theorem isn't just some abstract mathematical idea. It's a powerful tool that helps engineers and scientists like me understand and predict how fluids behave in the real world. And when it comes to designing things that fly, that understanding is golden. Now, let's shine a spotlight on those amazing vortex lines. Imagine them as tiny tornadoes, invisible to the naked eye, but oh so important for flight. These swirling lines are formed when air flows over the curved surface of a wing. Remember how the air on top of the wing moves faster than the air below? Well, this difference in speed creates a difference in pressure, and that pressure difference is what causes the air to roll up into these spiraling vortex lines. Think of it like water going down a drain. It doesn't just flow straight down, it spins and swirls as it goes. These vortex lines are strongest at the wingtips, where the pressure difference is greatest. They trail behind the plane like invisible ribbons, gradually losing their energy as they interact with the surrounding air. But while they last, they play a crucial role in generating lift. How, you ask? Well, those swirling vortex lines create a downward flow of air behind the wing. And, according to Newton's third law, every action has an equal and opposite reaction. This downward push of air results in an upward force on the wing, lift. So, the next time you're gazing at a plane soaring through the sky, remember those invisible vortex lines, the unsung heroes of flight working their magic behind the scenes? Hold on tight, because we're about to enter the spin cycle of aerodynamics. It's time to talk about circulation, a concept that's deeply connected to those swirling vortex lines we just explored. In simple terms, circulation is a measure of the spin or rotation of a fluid around a closed loop. Think of a hula hoop. The air inside the hoop is circulating, moving in a continuous loop. Now here's where it gets really interesting. Circulation is directly related to lift. The more circulation you have around a wing, the more lift it generates. It's like a spinning top. The faster it spins, the more stable it becomes. Similarly, the stronger the circulation around a wing, the more lift it produces, allowing it to soar higher and more efficiently. But here's a head scratcher. How is circulation created in the first place? Well, it all goes back to those amazing vortex lines. As those swirling lines form and trail behind the wing, they induce a circulation in the surrounding air. It's like a domino effect. The vortex lines create the spin and the spin creates the lift.